questions 5 through 7 on the 2013 grade 12 Euclid math contest. Tanner has 2 identical dice. Each die has 6 faces, which are numbered 2, 3, 5, 7, 11, 13. When Tanner rolls the 2 dice, what is the probability that the sum of the numbers on the top faces is a prime number? Well, we have unconventional dice. Normally it's 1 through 6, as you are well aware, but this time they've got these numbers instead. Now, any probability question is usually a fraction, and the denominator is the total. So if we are rolling 2 dice, we're going to have one number that appears on that first dice and another number that shows up on the second dice. So I've got 6 possibilities for that first number and 6 possibilities for the second. So the total is 36. So that's what goes in the denominator. Now my task is to figure out the numerator. So here we go. So since 36 is not that many, I can write them all out. So if my first dice or die, whatever the plural, singular, whatever, is a 2, then the second can be either 2, 3, 5, 7, 11, and 13. So what I'll do, I'll just write out all the combinations, then we'll come back and talk about the sums. All right, so these are the 36 possibilities. Now let's talk about the sums. So I'll put the sum right beside it. 4, 5, 7, 9, 13, 15, right? Those are the sums of these 2 rolls. And in a very similar way, we'll write out the sums for everything else. All right, now let's circle any sum that's a prime number, which is what they want. Well, let's see. This is prime, this is prime, and this is prime. And then in the next one, just the 5. The next one, just a 7. And let's see, any more prime numbers? This one is prime. And I think that's it. We get a whole bunch of even numbers, and even numbers are not prime unless it's a 2. So I think that's it. So I got 6. So the probability is 6 over 36. And of course, they're going to want you to reduce that to lowest terms, so that's 1 over 6. No problem. In the diagram, V is the vertex of parabola with the equation y is equal to negative x squared plus 4x plus 1. Also, A and B are the points of intersection of the parabola and the line with the equation y equals minus x plus 1. Determine the value of AV squared plus BV squared minus AB squared. Okay, so the first step is we want to figure out the coordinates of that vertex V. So we can do that by completing the square on y is equal to minus x squared plus 4x plus 1. So factor out a negative 1, and when you do, you get x squared minus 4x minus 1, like that. And then now let's complete the square. So you're going to take half of this coefficient and square it. So half of minus 4x is minus 2. Square that and you get positive 4. Immediately subtract that, and don't forget about that negative 1. And now these 3 will be able to factor. So we got x minus 2 squared. And then these 2 we'll have to kick out of that bracket. So it's minus 5, but then when you multiply by that negative 1, it becomes plus 5. So now that it's in this form, we know that the vertex is 2, 5. So this is 2, 5 up here. Okay, now we have to figure out the intersection points A and B. Well, that's pretty straightforward. You just set these 2 equations equal to each other. So that means minus x squared plus 4x plus 1 is equal to minus x plus 1. So the 1's cancel, and then it's going to be just minus x squared plus 5x is equal to 0. And then if we factor out an x, we will get minus x minus 5 is equal to 0. Plus 5, and therefore that means x is either equal to 0 or x is equal to 5. Yeah, so substitute those 2 values back into either one of those to get the values of y. When you do, you get y is equal to either 1 or minus 4. So 0, 1 is obviously A. 0, 1, and then b would be the other guy, which is 5, negative 4. So there we go. Now we have to figure out this last part here. And that last part is AV, so the distance between A and V, and then the distance from B to V squared, and then A to B squared. And then we have to figure out, of course, this relationship. Okay, so AV squared is the distance formula. So that's going to be using those 2 points A and V. 2 minus 0 squared plus 5 minus 1 squared. And then normally it's under the square root sign, but that would be AV. But since I'm squaring it, I don't need the square root sign. So that means AV, when you do this math, turns out to be 4 plus 16, which is 20. All right, let's move forward with BV squared. BV squared, that's going to be 5 minus 2 squared plus negative 4 minus 5 squared is 9 plus 81, and that is 90. And then finally AB squared, in a very similar way, 5 minus 0, using those 2 points squared, plus minus 4 minus 1 squared, and that will be 25 plus 25, and that is 50. So finally, if we were to evaluate this expression, AV squared is 20, BV squared is 90, and then minus AB squared, which is 50. So that's 110 minus 50, which is 60. So 60 is your answer. In the diagram, ABC is a quarter circle of a circular pizza and has a center of A and radius of 20. The piece of pizza is placed on a circular pan with ABC touching the circumference of the pan as shown. What fraction of the pan is covered by the piece of pizza? Well, we can deduce a very important finding, that if you draw a line from C to B, that's the diameter. And I said, well, how do you know it's the diameter? Because it looks like the diameter? Well, no. CB is diameter because that angle is 90 degrees. And if you remember, anytime you draw a angle within a semicircle, if it's going to be 90 degrees. So if this is the diameter, then of course this is the semicircle. And then when you draw an angle within it, it's going to be 90 degrees. So the fact that that is 90 degrees ensures that CB is the diameter. So if CB is the diameter, let's just say approximately here is a center. That means this is R and this is R. We'll just call that O for the center. Okay, that's a pretty good setup. And then they told me that the radius is 20 for that quarter circle. This quarter circle, it has a radius of 20. All right, so here we go. First thing we need to do is figure out R. Well, we can do that easily with Pythagoras. 20 squared plus 20 squared is 2R squared. 400 plus 400 is 4R squared. So 800 is 4R squared, and therefore R squared is equal to 200, and therefore R is the root of 200. Okay? So now what do they want us to figure out? The percentage of the pan that's covered by that quarter circular pizza. So in math, basically it means the quarter of the pizza is pi r squared divided by 4, and then how much of that is covering the large pan, and the pan is a one full circle, so pi large r squared. This fraction is basically what they want us to figure out. Okay, well the pi's cancel from top and bottom, so all you're just left with is r squared over 4 over big R squared. R squared, well the small r is 20, so that's 20 squared over 4, and the large R is this guy right here. We just figured that out, 200. So this is my math. Let's see what this comes out to. 20 squared is 400. 400 divided by 4 is 100. So it's 100 over 200, which is a half. So I don't know if it's just me, but for some reason that quarter pizza looks like it covers more than a half. But I don't know, maybe that's just me. That is indeed the correct answer, by the way. The deck AB of a sailboat is 8 meters long. Rope extends at an angle of 60 degrees from A to the top M of the mast of the boat. More rope extends at an angle of theta from B to a point P that is 2 meters below M as shown. Determine the height MF of the mast in terms of theta. All right, let's label as much as we can. Most of this is already labeled. But M to P, that little distance right there, they're saying that is 2. And then I think that's it. I'm going to have to label AF something, so I'll call it X. And then since A to B is 8, FB will basically be 8 minus X. And I think that's all we need for labeling. All right, here we go. Tan is what we're going to use. Tan of 60 on this triangle right here is MF over X. And therefore X is going to be MF over the tan of 60. We are also going to use tan on this triangle over here. And there, that angle is theta. So we have tan of theta is equal to PF. But PF is really MF minus 2 and over 8 minus X. So 8 minus X is equal to MF minus 2 over tan of theta. Okay, so we can substitute this guy here, and let's do that. So we have 8 minus X, but X is MF tan 60, and that is equal to MF minus 2 tan theta. So at this point, we just have to crunch out this and come to a final conclusion. This is pretty much going to lead to that. All right. Well, what is, let's see here, MF, what is the tan of 60? I think it's root 3, right? Yeah. So then we just continue here, MF minus 2, tan of theta. Put all the MFs on one side, and then that will give you MF over root 3 plus MF minus 2 over tan. And we've got this kind of unorthodox fraction. So to a common denominator, root 3, tan theta and tan theta, multiplying top and bottom here. So I've got 8 is equal to MF tan theta plus root 3 MF minus 2 root 3 all over root 3 tan theta. Okay. All right, let's continue. Let's cross multiply. Or is that the right thing to do? Yeah, I think so. 8 root 3 tan theta is going to be equal to MF tan theta plus root 3 MF minus 2 root 3. Okay, bring the 2 root 3 over, and we get 8 root 3 tan theta plus 2 root 3. And then on this side, I'm going to factor out the MF. So I've got tan theta plus root 3. And then I think that's it. I can isolate for MF finally. 8 root 3 tan theta plus 2 root 3 all over tan theta plus root 3. So not pretty, but it does give us what we want, which is MF in terms of theta. And perhaps they want you to rationalize the denominator by multiplying top and bottom by the conjugate, which would be tan theta minus root 3. And I'll let you do that. But this is pretty much the answer. And 8 root 3 tan theta plus 2 root 3 over tan theta plus root 3. Okay, so there we go. If 1 over cos x minus tan x is 3, what is the numerical value of sine x? Let's work with this. 1 over cos of x minus the tan of x is equal to 3. And then eventually we want to figure out the numerical value of sine x. All right, well, 1 over cos of x, convert tan into sine x over cos x. like that, is equal to 3. So we got 1 minus sine x is equal to, over cos x is equal to 3. And let's see what we can do at this point. Let's isolate, putting the cos x on one side. I think at this point, probably best to square both sides. If you do, you get 1 minus 2 sine x plus sine squared x. And on this side, you get 9 cos squared x. The reason we do that is because it will allow me to put everything in terms of sine x, because there's the famous identity cos squared x plus sine squared x is equal to 1. So cos squared x is equal to 1 minus sine squared x, like that. So let's substitute that in. And when you do, you get 9 times 1 minus sine squared x, right? So now let's do some number crunching here. 1 minus 2 sine x plus sine squared x is equal to 9 minus 9 sine squared x. Put everything on one side. And when I do, I get 10 sine squared x minus 2 sine x minus 8. Okay. And let's see, I think I probably can divide through by 2. That will give me 5 sine squared x minus sine x minus 4 is equal to 0. Now let's see if this factors. And 5 sine x, and then I believe 4 and 1, and then the signs would be positive and negative. Yeah. So that means that the sine of x is equal to negative 4 over 5 or 1. Okay. Well, let's see what the angles would be. If the sine of x is equal to 1, that would mean that x is equal to 90. And therefore the cos of x would be 0. But the cos of x is in the denominator in our original expression, so that's not possible. We can't have a 0 in the denominator. It would make it undefined. So this scenario is no good. So that means the only value of sine x that is legitimate is minus 4 over 5. And I think that's it. That's what they wanted us to find. So that takes care of 7a. Determine all linear functions f at x is equal to ax plus b such that g at x is f inverse x for all values of x. And then f at x minus g at x is 44 for all values of x. So they want us to figure out all possible f at x equations that's going to be of that form. And then they told me that g at x is the inverse. Okay, so let's first figure out what is g at x. Well, when you have an equation like this, to figure out its inverse, if this is f at x, which it is, to figure out the inverse, which would be f at negative 1x, you have to essentially just switch the x's and the y. Wherever the x is, you put a y. Wherever the y is, you put an x. So it would be x is equal to ay plus b. And then isolate for y. So x minus b is ay, and therefore x minus b over a is y. So that means that g at x is now x minus b over a. Okay? So there's no tricks here so far. That's it. So now they want you to look at this equation that f at x minus g at x is 44. Always. All right, let's put in my f at x. It's ax plus b, and my g at x is x minus b over a, and that's equal to 44, always. Okay, so I've got to somehow manipulate this. Let me just break it up into like terms. So this is going to be x over a plus b over a. And let's put the x's, it's going to be a minus 1 over a if I factor out an x. And then this will be b plus b over a, 44. So at this point, we have to start thinking, okay, what's the best way to proceed? I think the best way to proceed here is to understand that how is this going to be true? It will be true if this is 0. If that is 0, then no matter what you put for x, it's not going to make a difference because it'll just multiply by 0 and vanish. And then therefore this part will be 44. So I'm interested in making that equal to 0, that coefficient. That means a is equal to 1 over a, and that means a squared is 1, and therefore a is equal to plus or minus 1. Okay, so let's figure out that. First, let's do it for a equals 1. Now I have to solve this part of the equation. Okay, so b plus b over a is 44. And first let's do it for a equals 1. If a equals 1, then I've got b plus b is 44. So 2b is 44. That means b is 22. Okay, that's my first finding. Now let's do the same thing for a equals negative 1. That would give me b minus b is 44. So that means 0 is 44. Well, obviously, that doesn't work. So the only solution looks like a is 1 and b is corresponding to 22. So that means the only such f at x I can find is a equal to 1. So it'll be 1 times x plus b, which is 22. So if I were to write it out, it would be f at x is equal to x plus 22. And that's it. That's the only, they say all linear functions, but interestingly, there's only one. And when they say all, it tends to confuse people because it makes you think that, oh, there must be more and I don't know what I did or I didn't do the right thing. I don't know why they do that. Just determine the linear function. Why put all? But it's a math contest and they're just trying to be complete. And that's it. That's the answer for 7b.